Hello everyone, welcome back to Unbound Coder. Here we break the limit with code. So today we'll see that a new and very important interesting problem, that is 01 knapsack problem. So what the problem say that you are a what you are assume you are a thief. Okay, you go a house and you see, and also you have a capacity. Okay, you have capacity 5. Okay, so you take a bag with capacity 5. Okay, and there is multiple item. I assume there are four item with profit 3 6 2 8. Okay, and every item have also a every item have also a weight. So I assume it like 2 3, then like 5, and like, okay, there was 2. Okay, so give me the maximum profit. Okay, give me the maximum profit. This is the question. So how you pick it? If you see that our knapsack is the two types problem. One is fractional knapsack problem and another is 01 knapsack problem. So in fractional knapsack problem, what say that you have also a capacity, but what you see that you pick any of the item, any amount. Okay, but here you if you pick this, so if you put this or not take this. Okay, take or not take, take or not take. Okay, and every time check the weight. Okay, if it's cross the boundary, then you not take it, means cross the capacity. So here what you thought, this is a dynamic programming problem. If you it solve it by recursion, then it give exponential. Why? Because I have two choice. I take or not take. Okay, okay, so in main function you return that. What you return, I first solve recursion, then memoization, then tabulation, and then pace optimization. Also I see you here the single array pace optimization. Okay, and in the every code in description, so don't worry. Okay, okay, so in main function you write that return my function of from last, so n minus 1. And what is my capacity? My capacity is 5. Also you pass the value and you pass the weight. Okay, okay, so then you do the main function work. मतलब जो sorry, you work this function. Okay, so you write I index I and capacity, and you write value and you write weight. Okay, so you first of all thought that if I not take, then what is my profit? Okay, so if I not take, then my profit is 0. So not take means my profit 0. So where I go index minus 1, just before element item. Okay, so 0 plus f of for I write I minus 1. And for capacity is same as it is, because I not get any weight, so capacity as it is, and value and weight. Okay, okay, but if you take, first of all, you not pick up any item that exceed the capacity. Okay, so what you write, that first of all you assumption that take equal to my 0. Okay, okay, then you write that if one condition check if my weight of I, okay, my weight of I is greater than equal to my my main capacity. Okay, my capacity. So then you will write that what will give my profit, value of I plus. Now where go, now if it is take, then go here. Okay, so you write I minus 1. Also capacity also decrease, sorry, capacity is same. Okay, sorry, I say one thing, that capacity is now, capacity minus capacity my 5. If I pick 2, this element, then 5 minus 2, now what the capacity? 3. So I write cap minus my weight of I and comma value and weight pass. Okay, that's. And lastly, what I return maximum of take comma not take which give maximum. This is my answer. So here what is my base case? So you assume that I have only one element. Okay, when you write the base case, you assumption that you have only one element. So what you write? You write that first of all you assume that this is my value which is give 5, and this is my what's it, wait, this give also 10, so I don't pick it. Okay, so also this check, if my weight of 0, if weight of 0 greater than equal to my capacity. Okay, then what I write? Then I write that what, return my value of 0. Okay, okay, that is my answer, and nothing. This is each recursion. If you see here, what is the time complexity? Here time complexity exponential, because function already every time call. Okay, so you need to optimize it. So if you optimize it, you need dp. So how many, which dp need, 1 ddp or 2 ddp? Here need 2 ddp. Why? Because you are changing parameter is n minus 1 and capacity. You see n minus 1 capacity change, so need 2 ddp. When you write 2 ddp, pass in function. Okay, everywhere pass in function in dp. Okay, here also dp. And you here write every time when function call, just before you check if my dp of I comma cap means capacity is not equal to -1. Why -1? Because I initialize a dp which initialize all are -1. So I write if it not -1 means previous any of item pick and give this value. So I minus is not -1. So I return dp of I comma cap. Okay, so here what is the what is the time constant for 2 ddp? I need big O n square time complexity. And what is the pace complexity for 2 ddp? Pace complexity big O n square. Also for what, recursion stack extra auxiliary pace. Okay, so I don't need extra auxiliary pace. So what I do tabulation. Okay, so in tabulation, as it is same, if my memoization is what, if my memoization is it, what's it, top down, so my tabulation what, bottom up. So you see here in -1 to go 0. So you first of all base case you handle that if for I is equal to 0 to like means our weight of 0, capacity anything. So you write my I capacity means I write the base case for tabulation. Okay, you not okay. I write the base case. So for I is equal to 0, I greater than equal to cap and I plus plus, and this is, and every time check if, here is check if my weight of 0 is greater than equal to I, means this I. Okay, so you write that my dp of 0 comma I is my capacity, means sorry, value of 0, sorry, my fault, value of 0. Okay, then you normal write for the tabulation approach, two for loop needed. So you write for 2ddp, two for loop needed. So you write for, I think this is the right false every time 3ddp also two or sometimes 2d also. This is the not the sure that 2ddp need two times. Okay, so you write for changing parameter I n minus 1 to n minus 1 to 0. So I handle the 0 case, so I write for I equal to 1 to laker n. Okay, okay, so if you write n means n minus 1, it's go n minus 1. And for dp array you create capacity plus 1 because 0 index. So you write for when you create the dp you write capacity plus 1 and n comma capacity plus 1 dp array you create. Okay, so I went and for same to same capacity you write c equal to 0, c greater than equal to my capacity and c plus plus. And as it is, take not take first. If you guys not take, then 0 plus dp of I minus 1 comma cap. Okay, and if you take, first of all assume my take is 0, and if this is the case you check, which I see, which I show you in previous, then you write my take equal to value of I plus dp of I minus 1 and capacity of weight of you write weight of I. Okay, okay, capacity not c, here c, so c minus weight of I. Okay, and lastly return dp of what I comma cap equal to my, what you write, I comma cap equal to my maximum of take comma not take. Okay, okay, so this is tabulation. So here what is my pace optimization? So here pace optimization is big O n square, means not extra auxiliary pace need, and time computer also big O n square. Okay, so if you see my previous video you see that where I write I minus 1, they are also have, a concept which previous concept. Okay, so using this previous concept you also convert it into ddp. Okay, but for 1 ddp you need to simple change of something. What you change, you see that I see one thing. Okay, sorry, my page खत्म हो गया. So okay, so here you see that when I create my dp array. Okay, so here you see that dp of I minus 1 and capacity it depend. So I minus 1 means which, if you see there, so needed I minus 1 here. If I here, so I minus 1 means here, minus capacity means here. So needed this, so just filling this. So what I do now, if I do traverse backtrack, so what I write, if I start from here, so I minus 1 to I minus 1 and capacity. So just a normal single array, if you write I minus 1, because this is a not change, so I minus 1 also you get. So you just change instant, where you write just change here. When you write it, see that and change here, current value change here. Okay, this is my, assume you see my previous array 2, 3, 5. Okay, and 9. So when you write here you see my 5, so 5 or something you calculate, you cancel it and write 6. Then when you write here you see that value and change here, same to same. Okay, if you do it, your time complexity is big O, big O n square, but pace complexity is big O 1. So hope guys you understand it, and I try to give my best in this example. Okay, and keep coding, keep growing. Tata, bye bye.